Generative ecologies is a productive environment where human and other living organisms interact with each other both digitally and physically. The current urban issue here is that 92% of people in the UK are not exposed to the outside world due to the addiction to digital technology, which causes disconnection of human and the outdoor environment. The question here, can digital technology itself be the solution of cyber addiction? Through advancement of technology, it increases the human ability to sense autonomously the current condition of their own health and environment. This integrated system is efficient to bridge between people and the environment, redefining interaction and moving away from digital network to physical space for hybrid conversations between human and machines. We are building a prosthetic ecosystem that is anticipated to go along with people's daily routine. The design objective is to encourage an appropriate level of human interaction without disturbing equibalence. Microclimate condition is dependent on the quality of sunlight and humidity, resulting in different microclimate ecologies. For example, humid sunny, dry sunless, humid sunless, and dry sunny. Interlocking is one of the ways to connect between human activity and environment. It is able to offer a variety of spatial configurations, which provide opportunities for people to customize their own outdoor spaces. Using a specific H-shaped element, defining 6 directions, it has 2 ways to interlock. We discovered that there are 4 types of arrangement that can grow endlessly. And the rule for aggregation all follow to the edges of a 3D box grid. Based on these 4 basic types of configuration, it can aggregate according to the spatial needs for both humans and ecology, and be customized into any wanted path through computational logic. Simulation of interlocking was then deployed to examine the performance of the configurations. There are 8 types of combination that can produce different porosity and individual humidity and wind climate. The optimization process is accomplished through multi-objective evolutionary algorithm, with having 3 parameters that include human aspect through human path, environment ecology through maximum sun exposure, and context to the city through maximum access to view from the site. This process allows to arrive to an optimum solution. The result is then processed with supervised machine learning that follow an open space-oriented urban pattern to quantify profit and public spaces in our urban block, such as residential, commercial, and corporate office. Looking into the context of Canary Wharf, through satellite image mapping, we identify regions around our site with high accessibility, free popularity, water runoff, and UVI, solar radiation, and dispersion of local ecohabitat. The topography is comprised of 4 different levels of control to create a coherent system from hard surface architecture to soft ground material, which then results in a generative urban network organization for both human and local species around our site. The morphology process integrates genetic algorithm result with site context and surface topography. Data from surrounding building heights, urban corridors in Canary Wharf, and landscape underground contribute to the final massing. The test for the multiple interlocking configuration results in more controllable building porosity, which is applied into different configuration in the computational grid. The running path is also generated in between the interesting spot, and using algorithm can generate different length and slope according to customized needs and porosities. Cave, Ring Road, and Valley are three cluster prototypes based on the relationship between running path and building. The microclimates of prototypes vary from one to another, thus resulting in the suitability of different environmental ecologies and outdoor activities. The establishment of a system requires us to research three essential characteristics of the Earth's surfaces: porosity, density, and flexibility. The environmental simulation process triggers the suitability for microclimates. Computational environmental simulations are run onto the design landscape as well as the building. Simulation of radiation, rainfall, and wind are applied to pinpoint the location of appropriate specific human outdoor activities, as well as ecohabitat. The result of simulations suggests the percentage of suitability on environmental ecologies in different microclimates. Based on the simulation result, the customizable structure can adjust in relation to humidity, temperature, and ventilation level. In this way, architecture can sense and respond to the needs of each living organism and individual. The structure in various different scales are integrated to sustain the lives of all living organisms, starting from the microstructure under the ground to the micro level for human outdoor activities and breathing building facade. We propose a symbiotic system where human and other living organisms can communicate and benefit from each other. This distributed network can automatically give feedback in terms of route customization based on personal health data and responsive structure driven by environmental needs. The process acts as an interface among people, plants, and animals. EcoFitness is a user interface where human and non-human users can interact between each other through a health mobile application. It serves as a bridge between human activities and local species. The generated path is designed to be personalized and customized according to the individual human data as well as ecology in the surrounding area. The project proposes a new artificial habitat that is interweaved into people's daily routine. This decentralized system can be modified to suit a particular individual's needs and immediately correspond to the habitation of an amount of time people spend outdoor. Visualizing the coexistence between human and local habitat, this digital structure enables a new empathetic relationship between people and ecology, redefining every surface as a breathing organ that can be customized by human beings and natural systems.